Hi, this is an example problem about energy. Pause and read the question. Okay, I've already written down the energy equation here. And if you think about this example, this is one where the work done by non-conservative forces is not zero. We know that because the helicopter is rising upwards. And it's not slowing down, it's actually gaining speed. Helicopters don't go up and get faster if it's gravity alone that's governing the motion. Therefore, there's some other force doing non-conservative work. In general, non-conservative forces can do positive work, which adds energy, or negative work which detracts energy. Things such as air resistance, friction, they do negative non-conservative work. They remove energy from the object. In this case, we'll see that the propeller is a propulsive force that actually adds energy to the helicopter so that it actually speeds up as it goes up against gravity. Let's start by drawing a picture of the before and after of the helicopter, the starting point and the final point. Just like we always do with energy, you got to look at what's going on at the beginning and the end in terms of the height and the speed. So there's the helicopter, and it starts down below. So here's the initial situation, and later on it's up here. There's the final situation. And of course we want to know what the speed is for the kinetic energy and what the height is for the potential energy. Let me go ahead and draw a scale for height first. So there's our vertical axis, and I'm going to call the bottom the 0 reference point. So H initial is 0. H final, do we know what that is? Yes, 8.7 meters, vertical distant, it rises above the initial spot. So H final here is equal to 8.7 meters. And we also want to try to figure out, do we know anything about the speeds, right? So over here, what's the initial speed? We do know what the initial speed is. Let's see, it starts from rest, right? So that's 0. And at the end, this speed is equal to a final speed of 10 meters per second. So we've got 10 meters per second. So we know all the speeds, we know all the heights, right? We are asked in this question, in the initial part here, what is the work done by the lifting force? So the propulsive force of the propeller is going to do non-conservative work. We are solving for the work done by the non-conservative lifting force here. Now, we've got a few zeros. Let's remember, right, that for kinetic energy, that depends on the speed, and for potential energy, that depends on the height. So wherever we find 0 values, we can cross out the corresponding energy value, right? So 0 initial height, P initial, 0. Actually, I see a typo here too. This is supposed to be the final potential energy. 0 initial speed, that means the kinetic energy, right? That guy is 0. And now we can go ahead and solve with algebra for WNC. I gotta say, well, that was easy. We didn't have to do any algebra. By plugging in our zeros, we already got it. And finally, let's go ahead and put in our equations for the kinetic energy. Not that one. 1/2 mv final squared plus mgh final. And when we plug in all of our numbers here, we're going to get a answer for the work done by the non-conservative force. Now you may have noticed in the previous problems where gravity alone acted and mechanical energy was conserved that we didn't have to worry about the mass, it canceled. But not this time, because WNC doesn't have a mass term. I can't divide by the mass, so I need to actually know what the mass is. Good thing we know it's 860 kilograms. We know what the final speed is. It's 8.7 meters per second squared. No, it's not. That's not a speed. That was 8.7 meters. Good thing I checked that unit. 10 meters per second squared, plus my mass, 860 kilograms. times gravity, 9.8 meters per second squared, and my final height is 8.7 meters. Plugging this all in, we're going to get an answer. It's going to be positive. This is a propulsive force. It adds energy to allow the helicopter to speed up against gravity. And the answer we get is this: 1.16 times 10 to the 5th joules of work. All right, now in the next part they say, what average power is generated by the lift force? Well, the average power, P average, is simply defined as the work done by a force. In this case, this is the lift force, the non-conservative work done by the lift force, divided by the time during which that work was performed or delivered. And in this case, we know what the work was. We just calculated it. So 1.16 times 10 to the 5th joules divided by 4.5 seconds is how long that took. And if we calculate this, this comes out to 2.58 times 10 to the 4th joules per second. Now, a joule per second is defined to be equal to a watt. Watt is the unit of power, so we can also write this like this: 2.58 times 10 to the 4th watts. That's the power delivered by the lift force in doing work on the helicopter.